Hello and welcome to Algebraic Expressions chapter, where the third topic will be factorization. What do I mean by factorization? Well, in the previous topic, we have been looking at expanding brackets. So we've been going from here to here, from here to here, here to here, and to here. But now what happens? We go from an expression to brackets on each one. And this is used using 5 different methods. Now I'm going to teach all these methods, and hopefully by the end of this video you have somewhat sense of what factorizing is, and you'll be able to factorize completely and simplify and be happy. Well, in this video we're going to learn 5 different rules, and first one is common factors. So first one, you can see that we have 3xy plus y, which simplifies into y outside. Now why is that? Because if we look at the common factors of 3xy and y, we can see that only y is the common factor. So we can pull out the y and we can write 3x plus 1, because if we multiply y by 3xy, if we get y by 3x, then you get 3xy, and y times 1 is just y, so it's the same as that. To put the numbers in brackets, you have to think of what do I need to multiply this expression by y to get a 3xy and to get to y. Simple, we just take out the common factor. In here, you use the formula, which is x squared minus y squared is going to be x minus y and x plus y. So what happened here is that this is 2x squared and this is 3 squared. So we get 2x and 3 plugged in the formula as 2x being x and y being 3, which gets us the following. And we also have those 3 here, which I be talking about in depth in a second. But no matter what factorizing it is, we always look at the common factors. Always. Always common factors. And then we can figure out if it's ax squared plus bx plus c, or if it is difference of two squares. So first one is 3x plus 9. Now how do I tackle with 3x plus 9? Well, I look at the common factors, because that's always what I have to look at first, and now 3 is the common factor. And now I need to fill in the bracket to make sure it multiplies out to get the same result as 3x plus 9. So I need to multiply by something like x to get 3x, and 3 multiplied by something like 3 to get 9. Now we have x squared minus 5x. In here, we look at the common factors first, always. So, if we look at the common factors, we can see that x squared and x have common factors of x. So, x is outside. And now, we need to think of something to multiply by x to get x squared. That's x squared. No, that's x actually, because x times x is x squared. And x multiplied by something to get us minus 5x. So that will be minus 5, because minus 5 times x is minus 5x. Now the common factor of 8x squared and 20x is going to be 4x. And now we think what does multiply by 4x to get 8x squared? This will be 2x. And what multiplies by 4x to give plus 20x? This is plus 5. So expanding these brackets gives us 8x squared plus 20x. And that's how you factorize the following expression. Now here we got 9x squared y plus 15x y squared. So what happens here is that we got 9 and 15. The factor of that is 3. We got x squared and x. The following factor is x. And y squared. The following is y squared. No, y. And here we write the rest. So what does multiply by 3xy to get 9x squared y? Well, this is 3x. And something multiplied by 3xy to give 15xy squared. That will be 5, x is already there, and y. So that's how you get to the factorization for this question. The last common factors example will be given as 3x squared minus 9xy. And now 3 and minus 9 will have common factor of 3, and x squared and x will have a common factor of x. So the 3x is outside, and the inside is x minus 3y. Because 3x times x is 3x squared, and 3x times minus 3y is minus 9xy. No matter what form it is, in here we always check the common factors. That is the rule. Now we will go to the form of ax squared plus bx plus c before the differences of two squares. Now x squared plus 8x plus 12 is in a form of ax squared plus bx plus c, where a is equal to 1. So when a is equal to 1, we use the third method where a equals 1. That's the coefficient. The a, the b, and the c are coefficients 1, 8, and 12. The value of a matters. In this case, it's 1. But if it was 2, we would need to use another method. But first of all, we need to find out how to factorize the first method. So in normal brackets, where you have x plus 1 and x plus 1, by multiplying those brackets out, you'll get x squared plus x plus 1, which is x squared plus 2x plus 1. Now notice that this quadratic is in ax squared plus bx plus c, and it comes out of those two brackets. So usually when you have factorization, it gives out two brackets for the following of ax squared plus bx plus c. Now notice that those two numbers, 1 and 1, and 1 and 1, when we plus them together, they give us 2, and when we multiply them together, they give us 1. Now, what happens in here is that we need to figure out what two numbers give to add 8 and two numbers that multiply to get 12. So adding together two numbers need to give us 8, and multiply into numbers need to give us 12. Now this will be x plus minus something and x plus minus something. We know that this expression will go into those brackets, but we don't know which number it will be. It could be this, which is incorrect. So basically, I'll show you my method of how I do it. So you always, when you have 1x squared, so a equals 1, you can find out two numbers that plus to get 8 and multiply to get 12. And we do that by writing all factors of the multiplier. So 1 and 12, 2, 6, 3, 4, and I think that's all of them. So now we choose one of them to add to get 8 and multiply to get 12. So 1 and 12 will not work, 2 and 6 will work, and 3 and 4 will not work. So 2 and 6 works because 6 plus 2 is 8 and 6 times 2 is 12. And therefore we put this in here. 6 and 2. And therefore we have our factorized expression. Now we look at the second example. Again, the a is 1. When a is 1, we can use the same method as before. So for the first time you see an expression, you need to ask yourself, does it have common factors? No, it does not. And now you ask yourself if it's a difference of two squares, or is it ax squared plus bx plus c form? Now this is clearly an ax squared plus bx plus c form, where a is 1, b is 3, and c is minus 40. Now we find out the two numbers that add to get 3 and multiply to get minus 40. So you write the factors of 40, 1, 40, 2, 20, 3, there is no 3, 4, 10, 5, 8, and I think that's it. So here, what we can do is that 1 and 40 is not it, 2 and 20 is not it, as well as 4 and 10. It will be the 5 and 8, because if I figure out how 5 and 8 will give us minus 40 multiplied and 3 to get added, I would have to do 8 minus 5. Because 8 minus 5 is 3, and 8 times minus 5 is minus 40. Therefore, this will be x plus 8 and x minus 5. Factorized. We look at two more examples before we go into where a is greater than 1. So x squared minus 5x minus 6. Again, we need to think of two numbers that add together to give minus 5 and multiply together to get minus 6. That will be minus 5 and minus 6. So I write all the factors of 6. And then here 6 and 1 will work, because if I do minus 6 plus 1, it gives me minus 5. And if I do minus 6 multiplied by 1, it gives us minus 6. Therefore, x minus 6 and x plus 1 is the following answer. And if we expand the brackets, x squared minus 6x plus x minus 6, we see that gives the same expression. So we factorize it correct. Now the last example, where we have 6 and 8. We write all the factors of 1, 8, 2, 4, and this will be 4 and 2, because 4 plus 2 is 6, and 4 times 2 is 8. So the factorization answer is x plus 4 and x plus 2. But what happens if we have 6x squared minus 11x minus 10? Well, now we know that a, the coefficient, is 6 and a is greater than 1, therefore we have to use another method for this. So what happens is that we do exactly the same, but we have to multiply 6 by minus 10 to get us minus 60. And we leave minus 11 as it is. We write out the factors of 60. So all possible combinations of numbers and multiply to get 60. And I think that's all of them. So now we have to figure out which numbers to give minus 11 and multiply to get minus 60. So this will not be it. This won't be it, this won't be it, this won't be it, this won't be it. This will be. So minus 15 plus 4. Minus 15 plus 4 is minus 11, which is adding to get minus 11. And then minus 15 times 4 is going to be minus 60. So we can write this as 6x squared minus 15x. Now notice that those two split, so basically minus 11 splits into those. Our answers, which we figured out. And now we have to divide it by 2 to factorize it. So the common factor of 6x squared minus 15x is 3x. And this leaves us with x, 2x actually, minus 5. We do the same for the right side, so 4x minus 10 gets also here 2 and 2x minus 5. And notice that these two are the same, so that means we can write it as 3x plus 2 and 2x minus 5. And why can we write it like this? Because 3x is times 2x minus 5 and 2 is times 2x minus 5. So this is the same as this. Now this expression has been factorized, and that's how you do it when a is greater than 1. And here we got another expression. First we look at the common factors, which are not there, and then we realize that it's in the form ax squared plus bx plus c, where a is greater than 1. So here we do the same as the last question, minus 10 kept the same, and here we multiply to get 24. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. Now to get to minus 10, we have to think. 1 and 24 will not work. 2 and 12, will it work? Minus 12, no, it won't work. And 3 and 8 won't work. So 4 and 6 must work, because minus 6 and minus 4 gives minus 10, and if we multiply minus 6 by minus 4, this gives us 24. So 6x squared minus 6x minus 4x plus 4. This gets split again. So what happens now is that we divide this expression and we factorize it separately. The left side first, so that's 6x and x minus 1 minus 4 x minus 1, and this is the same as saying 6x minus 4 and x minus 1. And if I expand this out, we get the same answer. So that's how you deal with ax squared plus bx plus c, where a equals 1 and a is greater than 1. Now let's see what is the difference of two squares. So if you have x squared and minus 25, and the following formula says x squared minus y squared is the same as saying x plus y, x minus y. Then we look at this and we see that x is squared and 5 is squared, therefore x minus 5, x plus 5. And that's it. That's what's different of two squares is. We just use the following formula to see if two negate each other and are squared. If they negate each other and they are squared, then we can put them into smaller chunks like here. And now we have another. First of all, we look at the common factors, and there is no common factors of 4x squared and 9y squared. So we go into saying if it's difference of two squares, or is it ax squared plus bx plus c. Well, it is not ax squared plus bx plus c, so it must be nothing, or it must be difference of two squares. So this is the same as 2x that is squared, and this is the same as 3y that is squared, and we got also the negative sign, therefore we can use difference of two squares. So that's 2x plus 3y and 2x minus 3y. And this cannot be simplified any further. Now factorizing this, we look at the common factors. The common factors of x cubed and minus 2x squared is x squared. And now we have x minus 2, so that is factorized. And here we just use the common factors to simplify this. Again, another question. Again, we look at the common factors, x cubed and minus 25x. The following common factor is x. And if we go rid of all of the common factors, we need to figure out what this thing inside is. Well, it is not in the form x squared plus bx plus c. And also we don't have any more common factors. Then we see if those are multiplied by 2, I mean squared by 2, so that's x, that's 5, and also we can see the sign that's negating, therefore it is a difference of two squares. So x and x minus 5 and x plus 5. Now we got another expression. So what happens here is that we look at the common factors first. Always common factors. The common factor of x cubed, 3x squared and minus 10x is x. So x and x squared plus 3x minus 10 inside. Now straight away I can see that this is in the form of ax squared plus bx plus c. So what I do is we factorize this one. So 3 minus 10. We write out those ones and we find out that this is 5 minus 2, because 5 times minus 2 is minus 10, and 5 plus minus 2 is going to be 3. So this is factorized to x, x plus 5, and x minus 2. Now we're going to look at some exercise questions. We know all the methods apart from the fifth one, and the fifth one is pretty special. So we know what happens when we have difference of two squares. We know what happens when ax squared plus bx plus c, where a equals 1 and a is bigger than 1. And we also know the common factors. But sometimes you can step on something that is to the power of 4 and to the power of 2 for the second one. And what you have to do is to replace it with y. And therefore, if you replace it with y, then you can get the expression, and we want to get to our answer by simplifying it to make it a quadratic. So now you can see that if we replace x squared with y, then you see that ay squared plus by plus c is in the form of ax squared plus bx plus c. And therefore we can factorize it, so whatever this is, and at the end we can replace the x's to get the following answer. There will be a question like this, so I will prepare you for it. But first of all, we're going to factorize 2x squared minus 50. Now we can see that the factor is 2, so x squared minus 25, and that's a difference of two squares because this is x and this is 5, and we also have negating sign, so that is 2x minus 5 and x plus 5. Now again we got another expression, and again we check the common factors, so x and x squared will give us x, and y squared and y will give us the factor y. So the overall factor is xy, and then we have y minus x. So if we multiply this out, this will give x y squared minus x squared y as required. But what happens if you have this kind of expression? Now let's see if this has common factors. It doesn't, so we exclude the common factors. So now, is it a difference of two squares? No, it's not, because there is no negation sign, and plus it is not a combination of two numbers, so we cannot use the formula. Now this is in the form of ax to the power 4 plus bx power 2. So that should be a rule 5. So what happens here is that I replace x squared with y to get 2y squared plus 14y plus 24. And now we can use our ax squared plus bx plus c rule where it's bigger than 1. So we multiply 2 by 4 to get 48, and we leave 14. Now we need to think of two numbers that multiply to get 48 and add to get 14, and those will be 8 and 6. And here we split it like so, just like before. We got 2y here, y plus 4, and we should get y plus 4 here as well, which is plus 6. So 2y plus 6 and y plus 4. But because we replaced x squared with y, now we have to y equal x squared. So what happens here is we just replace the y's with x squared to get the following answer. And that's it. This is how you factorize, and I hope this helped you. Make sure that you find the common factors first, and second or third and fourth and fifth. Make sure that you remember these rules, like the formula of x squared minus y squared, and that you find out the common factors first, and that you know what ax squared plus bx plus c, where a equals 1, or a is greater than 1, or when x is not the power of 2. You can change it into y, and then walk your steps through it. I hope this video helped, and that you have a great day.